Just to give you an idea about how we landed at where we are in field robotics, this is Kidston in 2017, where they were assembling solar panels in a production line approach and then taking those pre-assemblies out and dropping them into place. One of the challenges of this approach is getting the piles themselves to be aligned, and if the piles aren't in exactly the right spot, then the tracker systems and the mod rails and everything that comes behind it, including ultimately the solar panels, we tend to have a much harder approach and a much harder effort getting it all to fit together. So since the start of 2018, EIC's been working with UGL. We visited 5 of their active solar projects, and we've done some cycle time analysis with all of their more recent jobs, where we've really looked into every individual step that is involved in creating a grid-scale solar field. We've used that Lean Six Sigma process information to build a process model inside of our Signavio process simulation software. And I guess ultimately what we're really trying to do is kind of work out digitally what the optimum or the ideal process is in order to deliver a solar project. So it's inclusive of cost and materials and so forth. This automation part's specific to kind of the first stage of the solar job, which is the foundation stage. So for most projects, so for 6 out of the last 7, that's involved a driven pile solution. Tail and Bend's a special case, but for the other 6, it was certainly this sort of driven pile. Unfortunately, this is a highly repetitive and there is some risk in this process. It's two workers out in the field with a Vermeer PD10 pile rig. The piles themselves are dropped off the back of a truck, kind of just pulled off a trailer being towed behind a utility into the rough position, and then the PD10 comes along. The rigger rigs the pile. The PD10 itself lifts it vertical. He's obviously pushing that in square with the drive guide at the foot of the rig, and then driving that down into the ground. This is Bannington, which had relatively soft ground. So as you can see, that this is not sped up. That's the actual speed that pile drives in. So some of the jobs that can be quite quick. Some of the others, particularly the ones in West Australia, the drive time can be up to 4 or 5 minutes to drive it down into place. So yeah, on average, the cycle time per pile ends up being somewhere around 4 minutes by the time you track between and drive it in. Obviously, there's a lot of opportunity for human error.
My name is Tim Castle and I'm a robotics engineer at Universal Field Robots. I was interested in joining UFR because I had an interest in robotics, and there wasn't sort of many places around Brisbane or Australia really that were doing this sort of large-scale outdoor robotics. Jeff's idea was to sort of take these machines that are proven and reliable and make them robotic, and I thought, hey, that's a great idea, I want to be a part of that.
We first started off trying to pick avocados autonomously on farms. So that was where Universal Field Robots kind of started out, with the idea that we would be able to put a robot on top of a robot to then pick avocados autonomously all day, all night.
Since then, we've kind of pivoted and moved into construction and mining. Being a startup, Universal Field Robots enables rapid development. In the mechanical engineering space, it means we're able to conceptualize, prototype, and actually create products very rapidly.
UFR has a few industry projects at the moment. One of them is working with IMDEX to do downhole logging. The robot has to basically drive to a whole bunch of drill holes, align up the tool, and then autonomously winch down the sensor, and then winches it back up, and then autonomously drives onto the next drill hole. And it repeats that process, and it's a very nice application for the robot since it's a well-structured environment and it's repetitive.
It's been very exciting to work with UFR on this project, and particularly around the speed that we've gone from concept to the first prototype being field tested inside 6 months. And I think it's a great boon for Queensland's robotics industry going forward, and it shows the value of where discussions and collaboration can lead to.
We're a global company and we plan to use this technology everywhere and elsewhere. The next one's going to be in Chile at a copper operation. That'll be a fascinating operation to work at because it's neighbouring a city. They have all sorts of restrictions and difficulties, and we plan to use this tool to see how we can alleviate some of those problems.
So EIC met you FR at the ICRA International Robotics Conference, which was actually held in Brisbane last year, and we immediately saw the application that what Jeff and his team is trying to do to take a bog standard next-gen Caterpillar piece of equipment and fit it out with some smarts, LiDAR sensors, set of stereoscopic vision cameras, and enough computing power to understand where it is and really interact with its environment without any human operation. Very quickly we sort of talked about the opportunities that we could take with that, and we came up with this concept of using Jeff's technology to drive piles in for UGL. We worked through a project across 5 phases. Each of those phases had a go, no-go, where we were able to abandon the project if the technology didn't stack up. So we kind of spread that out. Unfortunately, we scoped this up towards the end of September last year, and that kind of aligned with some the collapse of the solar industry in Australia. So that kind of put things on the back burner, and we didn't go ahead. But in the interim, Jeff's company has been continuing with developing out their roadmap and developing out their technology. The demo on the screen here is from earlier this year, where they were demonstrating their collision avoidance algorithm, so that the thought here is that the robot would be able to operate in a congested environment with other workers, human workers, walking around it, and it would be able to sense its environment and using both its vision and its LiDAR to work around. Back in May this year, we also talked to Linewide about possibilities for machine automation of the drilling scope. They've got about 65,000 holes to drill. UFR was one of 3 companies that provided an option to the project. The project's gone with the incumbent, which is Heron Connect, who built the rigs for previous jobs. So they're going that way. As far as UFR goes, EIC decided that we really had some opportunities here that we wanted to try and get out into the group. So what we organised was a field day last month to demonstrate a couple of these technologies. UFR was one of 4 companies that we asked to come out and do a demonstration. We had about 30 people there from all of our operating companies, and as you can see in this picture here, the UFR guys have continued to develop the solution, even though we haven't commercially committed to them yet. That they've built a gripper that uses its machine vision cameras to recognise a pile in a stack of piles, pick up its edges, and then obviously reach in, grasp the pile, and pick it up, rotate it through 90 degrees, and place it in a position where the Vermeer can pick it up. That Vermeer is actually belongs to us. That's one of UGL's 6 Vermeer PD10s that they own. It's not being used at the moment because we don't have any jobs, so we have lent it to UFR to help push this project along. So it's our gear with their brain in it. So we're probably about halfway through phase 2 of our sort of 5-step program. If we decided to commit to this, they could probably have a working solution ready to drive piles inside of maybe 3 months. And that's quite exciting. We also obviously have quite a few other opportunities. The concept of a universal robot that we can use outdoors and attach a different head to, depending on what we're trying to achieve, whether that be the solar pile automation, which is where we started, or the concrete drill stuff that we did with line wide, or potentially any of the future tunnel projects. But there's a lot of other high risk activities that I think would be well placed for field robotics. A good one that we picked up when we were in Perth earlier in the year is temporary road barrier placement. So we put a lot of people in harm's way with Franna cranes in live traffic with traffic control in place, obviously picking up temporary road barriers off the back of trucks and placing them down onto the pavement. So the concept that we could use a tool like this to place those temporary barriers without having any humans in harm's way is well worth exploring. So there's certainly I would see this as the first step in a large spectrum of field robotics opportunities that we might be able to pull together. The company itself, UFR's wholly owned by Intech Engineers, who's Jeff Sterling's company. So really, we're just dealing with one person that owns the company itself. I've spoken to Jeff at length about opportunities for the future, and I'm sure he'd be open to CIMIC taking an equity position if that was the way we wanted to approach it. They're a fairly small, agile company, and I think they've got maybe 10 or 12 employees now. They're based in Brisbane and only a few blocks away from CPB's office here. There's definitely opportunities for us to either work together as customers or even take an equity position in their company if we wanted to go down that route. And they're open to any of those things. Hopefully that is interesting. Thank you.